Hello everyone and welcome to this little tutorial, I guess, on how to simulate particles like water being emitted from a rotating object. And this is a question that came in from Facebook in the indie game developers group. And this guy was asking, I'm asking to create a physics particle system which will be responsive to the player spinning a rigid body. I want the particle system to appear as if water is being sprayed off of the object mesh inside the spinning rigid body. So take any mesh, spin the rigid body, and water sprays off of it. Right now, despite using collisions, matching the mesh shapes, and other tactics, the effect I would like is not there. I'm hoping someone will be helping me with this. Please, if you can, give me some guides. Cheers. So the thing is, he wants to match the mesh shape, and that's a bad idea. Why is it a bad idea? Well, because look at this ball here. The water being emitted from the ball does not match the shape. Well, yes, it matched the outline of the shape, because if you take the rotation center, well, the furthest point on the object with regards to the rotation center is the place where the water is going to be emitting from, but it never emits from any other part. So in my opinion, the best way to simulate this in a satisfying manner is to just use a circle shape emitter. And I mean, yeah, okay, you might say yes, but what if it's a rock I'm using? Well, it's the same story. All you need to do is make sure that the circle collider is inside your rock or your ball and that it emits perpendicularly to the rotation axis. That's what we want to do. So let's see this in action, shall we? Let's go and watch this in Unity. I have this little project I prepared already with a bunch of things. So let's first take the sphere here. I'm gonna deactivate gravity in the rigid body for now. And as you can see here, I have an emission controller script, and that emission controller references a particle system, which is gonna be a child of the sphere. This is my particle system here. It has been configured so that it has a radius of 0.5, which is exactly the radius of my tennis ball here. So that's why it emits exactly out of the edges. But you could use a smaller radius. You want a radius that fits inside your object. That is the largest possible radius that fits in any direction from the center of your object. Essentially, that's what you want to do. And then you want, I'm using an arc of 360 degrees because I want to be emitting from all over the place. And I'm using a fixed angle spread to kind of emulate how, where is it? Oh, how it's going here, because you see the water is always emitted from the same point. And the reason it does that is because essentially it decides at some point, oh, there's a water coming out, and all the other water droplets are going to be drawn to that place and going to start emitting from there. It's just because water is drawn to water, and that's why it's emitting in this nice shape. So we want to reproduce that kind of similarly. Now this is way more random here, but yeah. What can you do? I mean, you can work out something to make it even more realistic, but I think this is good enough. I give a spread of 0.1 so that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different things bursting out. If you want less, well, you increase the spread. If you want more, you decrease it. Yeah, you could do like that. And if you want 0, then it goes like this. Okay, so let's just stick with 0.1, okay? Because I like it like that. Yeah, but what we want to do is to control the amount of emission according to the speed at which the ball rotates. The faster it rotates, the more water we want to come out of it, and also the bigger the speed we want to give to those particles. So this is all the things that are going to be driven by this emission controller. I have an angular emission multiplier that multiplies the emission by the angular speed, the angular velocity. I have an angular speed multiplier, so that's the speed of the particles multiplied by the angular velocity. Maximum torque and a maximum angular velocity, that is for testing purposes, because let's press play. So I've hooked in a little input reader so I can rotate my object. So if I start rotating it, you see that the faster it rotates, the more particles are coming out, and the faster they come out. I stop the rotation, the ball comes to a standstill because it has angular drag. Now the thing is, if I change the rotation direction, well, I want the ball to emit in that new direction. And if I go sideways, I always want to emit perpendicular to the rotation direction. How do we do this now? Well, if we stop here and we look at our sphere a bit closer, if I select the particle system, you see that I have the emission direction here. You can see the circle. So that circle has a forward vector, and I want to change the forward direction of this particle system according to the rotation axis. That's relatively easy to do. So let's jump into the code of my emission controller here. So here first I have all the serialized fields here with the things that are exposed in the inspector. We already saw about them. At the start, I set the rigid body's maximum angular velocity to whatever I determine is fit. I put 100 in there. The reason is that by default, the maximum angular velocity is very low of an object. So if you want an object to actually rotate properly, you need to modify this. So in my update method, I'm going to update the emission and update the particle's rotation. And then I have a fixed update here to apply torque by using the arrow keys, but that is not necessary. This is just so I can show you, hey, look at how it rotates along with the thing. So let's first look at the update emission. This is where we are going to define the speed of the particles and the amount of emission. So we first get the emission component of the particle system. We get the angular velocity of the rigid body, and then we set the emissions rate over time multiplier to a value equal to the magnitude of the angular velocity multiplied by our custom multiplier, which in our case is 25. And now we get the main particle system, and we then set the start speed of the particles equal to the angular velocity dot magnitude multiplied by the angular speed multiplier, which is our customizable value. Now this is the apply torque thing. I just add torque according to the horizontal and vertical axis. Nothing very interesting to see here. But this part here is the probably more important one. And this says, this updates the particle's rotation. So you get the rigid body's angular velocity, and then this is just for debug. And then I compare the normalized value of the angular velocity with the normalized value of the previous angular velocity. So what is previous angular velocity? Well, it was the angular velocity that I could read last frame. Now, if it's the same, if their normalized value is the same, then they point in the same direction. And so I don't need to change the rotation of my particle system, because I want my particle system to rotate along with its parent object. However, if they're different, then I want to realign it. And what I want to do is just tell it to look at the particle system.transform.look at. Look at what? Well, the transform position plus the angular velocity. So that's going to be a point that is going to be at the edge of that angular velocity vector when starting from the transform knot position. And so this is going to make sure that the forward vector of my particle system is going to be directed towards, well, towards the angular velocity in the same direction, if you want, as the rotation axis of our object. And because I have configured my particle system so that the particle system itself is perpendicular to its forward axis, then it's going to end up being perpendicular to the rotation axis. And then I just save the previous velocity to be sure. And that's it. And that's all you need to do. So let's have a look at it now with a little bit more action. Let's go into Unity here, back. Come on, Unity. Yeah, I have way too many applications open. Photoshop. Oh my goodness. And yeah, so now let's stop this here. And oh yeah, it was compiling, that's why. And we are going to put back the gravity on our rigid body here because I prepared a little playground for us. I prepared a little playground here. The lights are pretty bad. Let's change the lighting a little bit. Let's tilt our directional light. Come on. Why is my plane unlit? Oh, it is lit. Well, we'll see. So I set up, we were going to follow it anyways with the little Cinemachine camera. So let's see what happens. Let's look at our ball. It's going to fall, hit a first thing here, and it's going to start rotating. And as you can see, the direction of the rotation and the direction of our the way our ball rotates is going to influence the particle system properly. And now our ball rotates a little more. Let's go have a look at the sphere here. As you can see, the red line here is the rotation axis, and we are indeed emitting properly. So this is how you solve this problem, how I solve it anyways. Hope you enjoyed, and see you next time.